And in the meantime, we will move on to our second guest from the Geological Survey of Canada, which is Chris Lawley, who is going to give us an update on critical mineral research in that great northern country. Thanks, Chris.
Thanks, Helen. Is there a time when I should be stopping? Is there like a schedule to this?
Look, 20 odd minutes, you know.
Yeah, okay.
We're pretty casual.
Okay. All right, perfect. Well, thanks a lot, Helen and Vlad, for the invitation to speak to you today. I study gold deposits, which is not a critical mineral. And so I'm going to be presenting an overview of some of the geological research happening at our survey. So I'm going to be presenting other people's research, but I didn't want to just do an overview, so I created some new figures to show how production varies for these critical minerals around the world. So some of the figures are new, even though it's not necessarily all my research. Just trying to advance the slide. Okay, perfect. So Canada is a mining nation, which you probably, oh, it's a bit of a delay. So Canada is a mining nation, as you probably know. I study gold deposits, and so I was pleased to see that gold is one of the most valuable products that Canada produces. But we also produce a whole variety of minerals, including coal and potash, and iron ore, such as the Mary River mine up in Nunavut, copper and porphyry deposits and VMS, and nickel deposits all over Canada, as well as diamonds. So that Canada has, you know, a whole range of minerals that we produce. But we also are an important mining nation in the sense that we also have a large supply, service, and financial industry. So whether it's the TSX or all the companies that sort of support mineral exploration and mining, a lot of those are based in Canada too. And so that's really important to point out that not only is there a lot of mineral wealth in Canada, but there's also sort of all that support infrastructure, which is really how we get this stuff out of the ground. So you may know that Canada just released its first critical mineral list in March. And so the definition of the critical mineral list, as we saw it, was sort of all of the minerals, critical raw materials that we need for economic security. So this could be some of our conventional base metal deposits like copper, nickel, and zinc, as well as their byproducts, gallium, germanium, rhenium. They're critical raw materials that we need for our low carbon economy. So when we think about low carbon economy, what we're talking really about is electrification. So over 50% of our carbon emissions are due to either electrical vehicles or sort of energy production. And so the idea is that if we can sort of use renewable energy, we can cut out 50% of our emissions. And so a lot of the minerals on this list in Canada are minerals that are essential for those high-tech technologies to sort of support the electrification of our economy. And then what's kind of interesting about our list that's a bit different from sort of the US and European Union lists for critical raw materials is that we're also thinking about what our partners define as critical. And so as Canada sort of sees itself as a supplier of raw materials, we want to make sure that what we're focusing on is also of interest to others. And so the motivations behind the list were actually quite a few. So we wanted to sort of support supply chain development. So we want to sort of not only produce critical raw materials, but we want to sort of process them as well. And so we're thinking more in terms of how can we sort of support sort of these processing methodologies and sort of advanced technologies that you need for that. Also policy development and working with our international partners. So this is sort of, this list is just a list, but it's also sort of a vehicle, something that we can talk around with, you know, Australia or the United States. And also to support research and development. So we want our mineral research streams to be focused on things that matter most to Canada from a policy perspective. And so we're also looking at this list as some way for us to sort of identify what the highest priorities are for our mineral systems research. And so those are some of the definitions and motivations for the list that we just produced in March. Canada's already a producer of some of these critical raw materials. So here on the bottom here is just sort of the percentage of global production that Canada's already doing or was doing in 2019. The first tier on the list is cesium. So this is actually all from one deposit, essentially, the Tanko granite pegmatite deposit in Manitoba. We're also a major producer of potash, as I mentioned, in Saskatchewan. So that's what the K is there. And we have lots of large world-class mines of potash in Saskatchewan. And we're also a major producer already of niobium. So that's actually coming also from one deposit called the Niobek deposit. But what's kind of interesting about this list is that there's a whole range of other elements, critical raw materials, that aren't even really major producers on the global stage. And so that sort of goes back to sort of some of the motivations of creating that list to sort of identify the elements that are something that we want to focus on for future production. So as I mentioned, so one of the things that the list does is show us what we sort of already have strengths in, but it also shows us how we have to diversify our production into sort of critical raw materials that we're not currently major producers of. So that could include rare earth elements, niobium. So we only have one producing mine in niobium, and then lithium as well. And you can see that why these are critical raw materials. You can see that certain countries really dominate the global production. And so those countries that are dominating global production right now are highlighted in the yellows and oranges. And so geological surveys can sort of contribute to diversifying critical mineral production by giving data sets that support mineral exploration, but also to develop conceptual models for unconventional mineral systems. So a lot of the critical raw materials of the future will probably come from things that we don't really necessarily think of now as sources. And so Helen already touched upon sort of the sort of mine waste aspect. There's also brines, seafloor deposits, and deposits undercover, which is something that Australia has been thinking about a lot for a long time. But it's also something that's happening in Canada as well, as our mines go deeper or in areas that are harder to explore because they're covered by glacial sediments. So our main mineral program is called the Targeted Geoscience Initiative. TGI. It's sort of it's one of our core programs at our survey, and it just was renewed for our 6th phase in 2020. So we've been working on TGI for over 20 years. And I did my master's in TGI 3. I was hired during TGI 4, and now it's TGI 6. So I've seen a few of these go by, and each one comes with a bit of a different flavor. And this latest phase of TGI its flavor is a critical mineral. So when we look at sort of the breakdown of how TGI is distributed, we have the sort of ore systems arm. So this is where we sort of develop a lot of the conceptual models. In this case, we're really focused on critical minerals for this next 5 years. And then we have this digital geoscience arm where we're sort of developing a lot of the methods that support mineral exploration or support geological modeling in some way. And I really wanted to sort of plug right now that all of these results are free. So if you go onto Geoscan, so search Geoscan into Google, that's where really how the GSD speaks to the world. So everything that we do comes through Geoscan. So if you're interested, I really highly recommend you go into that website and also sign up for the RSS feed, because then you get updates on what we're producing. It's also great to see like who's working on what. So if you're new to Canada, if you want to start exploring in Canada, you want to know some of the research scientists or an overview of the research happening, it's a good opportunity, a free opportunity to sort of see what's happening. I think our bread and butter for TGI is sort of these conceptual models. And so this figure is from our colleagues here in Ottawa who work on uranium ore systems. So it's sort of this sort of thematic research where people go all across Canada and sort of look for the best examples of the process of interest. And then they develop these conceptual cartoons that sort of bring all of those different pieces together to identify the most important processes that go into developing, to make an ore deposit. And so these conceptual models are really, really important in places in Canada where there's not a lot of data. So all we really have is these conceptual models because we just don't know very much about the area. And so that's one of the strengths of the TGI programs, to develop this kind of thematic research. And I couldn't resist putting a little bit of my own research into this. So one of the great things about TGI and focusing on processes is sometimes you get to go to areas that aren't even mineralized. And so that's actually my research for the last 5 years, been sort of esoteric. I was really interested in understanding the process of gold upgrading in the mantle. And so I would go to these sort of young volcanoes. In this picture in the bottom left, this is a Holocene volcano. They would spew up mantle xenoliths. I would sort of study the mantle xenoliths, look for mantle sulfides, and then sort of try to use laser ablation mapping technologies and develop those methods to sort of better identify how gold gets upgraded in the mantle, and sort of to understand how sort of source regions for magmas can sort of be pre-enriched in gold. And so that's sort of what TGI does. It's sort of the conceptual models, and then all the way to the sort of more academic style research where we're not even studying mineralized systems anymore, but we're studying the processes that may be relevant to those mineralized systems. The digital geoscience arm of TGI is sort of actually a new focus for us. So all of this artificial intelligence is sort of an area that we're sort of rapidly expanding into. And so this is the work that I did, that I and others did for the last couple of years, where we're sort of developing national scale prospectivity models. So we started with sort of magmatic nickel sulfide mineral systems. And the reason for that is Canada is actually a major producer of nickel globally. And nickel is also really important for electrification. So whether it's the nickel for batteries or the associated critical raw materials like cobalt for batteries. And so this model on the right shows sort of the prospectivity for mafic, ultramafic systems all across Canada using a gradient boosting machines model, which was sort of the winner of an entire series of machine learning competitions that we ran for this particular mineral system. And so this model's nice, but what's really important is that we were allowed to, by doing this kind of work, we were allowed to bring our data sets together for the first time. So before we had sort of geophysical sort of databases and geochemistry databases, and they never really talked to each other. And so as part of this work, we're really excited and had the great opportunity to sort of bring all of those disparate data, all that disparate knowledge together. And so this work is published, and so is the data. So the data is freely available. So if you're interested in sort of downloading this data and playing with it, go for it. If you go to Geoscan, it's all free there. Yeah, and that sort of speaks to sort of the whole approach with Canada's critical mineral list. It's sort of that yin yang of sort of what, you know, our historic mining centers, we really want those to be strong, but we also want to sort of expand into new areas. And so that's why these critical minerals as byproducts is really important for us. So whether it's nickel deposits and the sort of the byproduct of cobalt, or whether it's sort of zinc-rich deposits that also have byproducts as like gallium and germanium and indium and antimony. And so this is really sort of how we're sort of starting this journey into critical raw materials. Europe has been doing this for a long time. Australia's been doing this for a long time, but for Canada, this is quite new for us. And so we're sort of trying to take what we already know and apply it in this new direction. And we're doing that with friends. So we're doing that with Australia and the USGS. And so I use zinc, gallium, and germanium as examples here because these mineral systems are associated with basin-hosted deposits. So our initial focus of our collaboration between our three countries is on sort of MVT and SEDEX deposits. And it's important because you can see in the plots here on the world maps that gallium and germanium and zinc, for that matter, are really highly concentrated. The production of those elements are really highly concentrated in China, for example. So that's sort of the rationale, the rationale behind our collaboration is to sort of work on bringing all of our data sets together as geological surveys to work on this common problem that we're facing. And so this sort of the policy driver of this sort of was in the last few years was from the US, and they issued a series of executive orders to sort of secure supply chains for critical raw materials. And so that's sort of, I think the geological surveys have an important role in that. We're just one piece of the puzzle, but we have an important role in the sense that we can sort of share in our knowledge and data more easily because it's all pre-competitive. And so we can really sort of lead the way on this sort of collaboration because we're already putting our data out there. And so I think that's sort of really our strength as surveys. And so far this collaboration has already involved over 44 scientists, from all three surveys. We already have sort of some scoping papers out to describe what our collaboration is going to look like. And of course, we also have that critical mineral forum that just finished up, where we had 18 countries, 29 speakers, thousands of participants, including Helen. And so we're really thankful that she decided to come and present as part of that. And all of that's freely available on YouTube. So if you want to check out sort of what happened, what geological surveys around the world are doing in the critical mineral space, you can go to that website and see all the presentations. We decided to focus as our three countries on basin-hosted mineral systems, really for a very simple reason that they're sort of really large-scale geological features. So as geological surveys, we want sort of to look at sort of the continental scale prospectivity, and basins that host these critical minerals are hundreds to thousands of kilometers long. So it's a real great opportunity to sort of look at the drivers and the continental scale pathways of these mineral systems. And so these are just two examples of sort of some of that work, how our surveys are already thinking about these things, but now we're just formalizing the sharing of knowledge and data between all three of us. So the figure on the left, the bottom there is Paul Lemzo's model. You can see the scale there. These mineral systems are hundreds of kilometers large. And then of course, Corral and all the Geoscience Australia folks published that in recent Nature Geoscience paper. The work that we've done is at the Geological Survey of Canada, what we know is sort of the better prospectivity models all start with data. And so I was really excited to be part of this work. All of our geological maps in Canada are actually done by the provinces. It's sort of a similar situation in Australia where territorial surveys do a lot of the mapping, but we had never actually combined all of the provincial data into one model. And so that's what this figure on the left here, it's the unified rock legend for 19 maps. And so this was a great project that I sort of started last winter. And now we've got it actually up and running and it's sort of working well. And then one thing that I think is really powerful that we did was actually use the rock descriptions, and we just built these dictionaries that could search through those rock descriptions to pull out different geological attributes. And so we can map out up to 17 geological attributes now across Canada. And so that's the figure on the right is showing. It's those green polygons are actually not actually mapped mafic or ultramafic rocks, but they're places where those maps have described the presence of those rocks. And so we think of the largest spatial footprints of mineral systems. This is what these sort of geological attributes really highlight. And what I haven't shown is that we can do this across Canada and Australia too. So we have a common rock legend now for all of Alaska, the US, Canada, and Australia. And we have these dictionaries that we can apply to all 3 countries as well. So this is really one of the foundational data sets for our data sharing and knowledge sharing. And I'm a geochronologist, so for me, geological time is really important. So one of the things that I think is kind of interesting in prospectivity modeling is that everyone sort of thinks immediately of the sort of spatial footprint of mineral systems, but as a geochronologist, there's also a temporal footprint. It's kind of awkward to say a footprint in time, but it is true, and we can map out geological ages. And so there's particular periods of Earth history that are particularly prospective for certain mineral system styles. So in addition to sort of the different rock types, the common rock legend and the dictionaries that we also have a common age information for all 3 countries now too. And so this is another really important piece of information that we can use for prospectivity modeling across all 3 countries. And so this is actually my last slide. I guess the summary is that sort of, this is sort of some of the work that we're doing at the Geological Survey. It's a small fraction. We have, we're a big organization. We have lots of researchers in the mineral system space. For instance, I'm only one gold metallurgist. We've got 3 others in Quebec and 1 other in Ontario. And so there's a lot of people involved in all sorts of different commodities. And all of that research is sort of focused through this one lens, which is TGI. The strengths of TGI are the public geoscience data sets, all freely available, and also the method development. And that's sort of another real strength of the GSC is developing analytical tools to help our ore system research, but also method development for actually exploration techniques as well. And everything's available on GeoScan, and you can sign up for our RSS feed to sort of stay up to date. And then the figure on the right is just showing sort of some of the challenges in Canada. A lot of Canadians sort of hug the southern border with the United States of America, but there's a whole bunch of Canada that goes up north, and a lot of that's undeveloped. And so there's a huge potential, just like in Australia, for finding new deposits. And that's really, really important for critical raw materials, because we know that recycling is not going to be enough to sort of meet our demand for critical raw materials into the future. And so whether it's deposits undercover or deposits that are remote in Canada, these are sort of really important frontier exploration regions. And so with that, I just want to thanks again for Helen and Vlad for the chance to talk a little bit about what GSC is doing.
Thanks so much, Chris. That's awesome. So we do have some questions, and before we skip to Albert, we'll just go through those. So Louise, the first 3 questions are for you. They came in after Chris started, and we'll give people a chance to write questions for Chris as well while we're answering Louise's questions. So first of all, there is a question from Ian Wolfe. Are there any references related to deposits in Indonesia?
Well, unfortunately, I don't know of any, and I'm not familiar enough about the geology of Indonesia to know if it would be the proper setting. What I have found, though, is that our knowledge of the geological setting, besides the fact that it does need to be formed on continental crust, there's so much we don't know that, to me, the key ingredient to find prospective setting is if you find huge albitite corridor somewhere in your area, or any of the dynastic alteration facies that I've talked about over meters and hundreds of meters, then you should think about those systems. But I cannot talk further about Indonesia, unfortunately.
No, thank you. That's great. And Carlos Spear would like to know what would be the source of the hypersaline fluids?
Well, as a regional field geologist, I saved myself from this very key question. That's something that, you know, a lot of people are doing fluid inclusions, but when I see the volume of fluids that must have come in to form the albitite corridors along 10 kilometers long, and then I see the fluid plume doing one alteration facies after the other and after the other and after the other, I see the host rock losing so much elements, so much of its pore fluids. We suddenly see magma coming in. We see suddenly a facies just going to a lower temperature and then going back to a higher temperature. That means fluid ingress. So to me, I don't know where the fluid is coming from. We know that the signature, the footprint goes down to the mantle. So, and all I have been able to talk about really is what's going on, you know, from the 10 kilometer and up that we had exposed or, you know, differentially uplifted and things like that. But really, how far what comes in, to tell you the truth, I don't know. I just know what the fluid plume does. Thank you for the question.
Thanks, Louise. And then Henry Tabar would ask if you could describe more on the sample types and conditions you were getting the geochemistry.
So, like in Canada, we had fantastic outcrop. So I do realize that each time you arrive in an alteration zone, I confess it's a mess. It looks complex, so that's why I focus on alteration, facies, on the mineral assemblage. So if you're a splitter, you're not going to be very happy in those systems. You need to accept that all your samples will be not perfectly homogeneous because each alteration is a mess. But it doesn't matter because the change in chemistry is so huge that whether you have just a little bit of more albite or a little bit less of albite, your sample doesn't matter because you want to know if you have 2% sodium or if you can reach 8, 9, 12% sodium. So every sample will be a little bit imperfect. So I take large samples, I take the most homogeneous sample in the heterogeneity of the alteration, acknowledging it is heterogeneous, and then I take the most intense alteration all the time. Now, for mineral exploration, it's going to be different, but I'm a regional field geologist, and my job was really to characterize each alteration facies so that then people can compare what they have with beautifully illustrated alteration facies and then work things out. So, and my rock slabs were very distinct from my geochemistry. My rock slab had as many cross-cutting relationships of very different alteration facies. I stained all my rock slab to see the distribution of all the alteration, the potassic alteration, what it was linked to, the sodic alteration, what it was linked to, the magnetite, the hematite. So I worked things out with the rock slab, but took geochemistry of one alteration facies as much as I could. Thank you for the question.
Thanks, Louise. There were some good questions there. We've also had a question in the chat for Chris. Just remember that if you have questions, can you please put them in the Q&A so that everybody can see them when we answer them. Paul Hoykas has asked Chris if he could share the link for the Geoscan, I believe. Was that it for sharing the Geological Survey of Canada's data? So I think Chris is going to share that. And I had a question as well about the work that you've been doing on developing those dictionaries and those data systems and pulling everything together, because we've over the last few years gone through a similar process in Queensland, because we collect all the data from companies as they're doing their sort of annual reporting to the state government, and of course each company calls a different rock a different thing, and somebody's basalt might be somebody else's morb or magnesium basalt, whatever, black rock, unknown, anything. But so we put a lot of effort into developing vocabulary so that what's recognised as what one person calls one thing can be recognised as, generally referring to the same thing. And I know some of that stuff has gone up to Geoscience Australia as well. And I'm not sure if that's the question because I'm not really involved in that work, but I was going to say perhaps if there's a really great opportunity for some of our data science people to talk to you guys and understand what you've done, share what we've done, and go through some of that.
Yeah, it's amazing how useful that is, and yet no one ever publishes these vocabularies or dictionaries. So trying to find someone, I know this work is happening, but trying to
connect
and actually use each other's information is sort of, there's a missing link there. So yeah, absolutely, that sounds good. I can't find out how to answer in the Q&A because I can't just type randomly. So if you want to share, I'm sorry, but I can't, unless someone asks something there, I can't just copy text.
I'll try and copy it to, if I'm clever enough. Here we go.
About that. Obviously, I want to share the link, so somehow we'll get it to people.
So I think it's all panelists and attendees. I'll pop it in there. There we go. I think that should go to everybody. So that's Chris's reply to the question about the open file data or the publicly accessible data.
Perfect. You just have to push the down arrow. Is that how you? Yeah. Okay.
Yeah.
Perfect.
Yeah. The drop down list. Yeah. All right. Well, thank you to the Geological Survey of Canada. And I did spend 3 years in Canada at the University of Calgary, so it's a place that is special to my heart. I miss snow, I have to say.